So hello everyone, welcome to the second video of our LLMOPS series. Hope you all guys are doing fine, and today we are going to learn about how to set up RAG and what is the basic concept of RAG, how to implement a RAG in a modular fashion, and some advanced RAG concepts also. So let's don't waste any time further, and let's start with the session. So let's go through what's the session agenda will be. So firstly we will go through the RAG concepts, like what is a RAG basically is, and we will implement it in a Jupyter notebook. And then secondly, we will set up the logger and exception module for our project. Then we will set up the config module for our project, and then the fourth we will set up the Pydantic models, which is basically type checking models for our project. And then we will implement the main multi document chat module for our project. And then lastly we will see some advanced RAG concepts. So let's get started with the first session's agenda, which is RAG concept, and let's see how to do it. Let's move on to understanding what is the RAG. So as we all know that what is a simple LLM call? Simple LLM call is basically we are just providing the input to the LLM, and the LLM is providing us some output. But in most LLM we know that the LLMs are trained on old data, like some previous data. But if you ask LLM some personal data, like what is my date of birth, what is my name, or for example some private data which the LLM is not trained on, then the LLM will not able to answer. But there is one case when the LLM will be able to answer if we explicitly mention them, if we explicitly give the information in the context. So RAG is basically the same. RAG is giving the context to the LLM applications in the form of some documents. Like here I have given that, okay, my name is Yash, I am 24-year-old and I live in Indore. So if I give this complete application this context, then if I ask my LLM that who is Yash and what is his age, then LLM will definitely answer me that, okay, Yash is a person who lives in Indore and his age is 24 years. So before giving the context, like in a simple LLM call, we are not able to give answer related to some personal queries. But if we provide the context to the whole application, the application will become more powerful. So this is how a simple RAG app work. And how this will work, we will understand this complete graph. But for now, stay with me. We will understand it while doing some code also. Okay, so let's do some code and then come again at this graph and you will understand it better. So let's move on to the Jupyter notebook and see how it goes. So this is our project, and as I've said you that before implementing or for understanding any of the concepts in our project, we will create an experiment Jupyter notebook first, and then we will implement the concept or the feature into our project in modular fashion. So for RAG we will do the same. We will create a new experiment like a RAG.ipynb notebook, and here let me just set up my notebook first. I will select a environment which is already set up, like here it is LLM series, and let me test that is it working fine or not. I will just add a print statement here which is hello, like the completion is given to me. Okay, so we can see that the Jupyter notebook is working fine. So let's go ahead, and for that, firstly for implementing a RAG application, we need to implement some necessary libraries. So this is the necessary libraries we want. I am just using UV here, and added an exclamation mark so that I can run terminal commands in my Jupyter notebook. And we are using these packages, some LangChain, OpenAI, TikToken, Rapid, like this one, and this one, and this one, like Python.env and LangChain community. We are using these packages. I will just run it and the UV will install it for me. And okay, so the packages are installed, and now we are ready to do some coding to implement our RAG application. For that we have our packages. Now we have to install. Now we have to set up our environment variable. For that we need to follow this command. Like here, we can see that we have imported our OS module, and then we are importing .env. Importing load.env from .env package which we have already installed, python.env, and then we are running it. So this line will basically load all the env variables present in the .env file, and it will load in our current environment. Okay, and now we are just setting that OpenAI API key equals to the environment API key with the name of OpenAI API key available. Okay, so we are just setting our environment key here. Now it is set up. Now let's move on to the first phase of RAG application, which is what is this? It's called data ingestion. Okay, so it's called data ingestion. Let me write down in the notebook also. Data ingestion. So what is data ingestion? Data ingestion is a pretty simple concept. Data ingestion means we are ingesting the data into the vector store. Like in the graph, you can also see we have some PDF, some text or some documents or some raw format, and we are just extracting the data and we are just ingesting it into a vector store. So this complete flow is called data ingestion. So how we do the data ingestion? We basically just extract the text, like extract data, like what we have done here. We have PDFs, we have text, we have documents, and we just extract the text data or the information in the text format. Okay, and then the extracted data will be divided into small chunks. Like for example, I have the text of 100, I have a paragraph of 100 characters. So I have divided this 100 character paragraph into 200 character chunks. So each chunk will be 200 characters. Okay, so here 5 chunks will be created. For example, take 4 chunks will be created. So for every chunk we will create embedding. So what is embedding? Embedding is nothing, it's just a list of number. Think of it as a list of number, but this list of number is created in such a way so that the semantic meaning of the chunk will remain the same in the vector store. So this is how embedding is done. So you don't have to do anything in the code. We will get embedding models. We will look how to do it in the code. Just be patient and be with me. So we have created an embedding from the chunk, and then we just store this embedding into a vector store. So what is a vector store? Vector store is a 3D space, you can say, a 3D space in which you can store points, like this point which you have created. Okay, so this embedding will be stored in this 3D space, and vector store will store the similar semantic meaning embeddings together. Like you can see in the demonstration, you can see that, for example, I have a vector store in which I have these different embedding store, like tiger, dog, cat, car, bike. So you can see in this vector store, this cat, dog, tiger is stored in a closed manner, like they are placed very close to each other. Like the tiger and the car are far, but the tiger and the cat are close. So we can say that the vector store is doing their work, and it is storing similar meaning letters together or in a shorter distance. So this is a simple concept in a summary of what is a vector storage. So I hope you got it, what is a data ingestion. So now let's code this flow. And for data ingestion, I need to import this text loader from LangChain. I will create a file here. In the data, I create a file like this file I have created. What is it? It contains some agentic AI information, like agentic AI refers to new paradigm and all. Okay, so you can see, and now I have this loader. So what this text loader is doing? Text loader is providing us a LangChain document with the content of the file given to it. Like this file content will we get in this loader, in this document, using this loader, and we also get some metadata in it. We have this document, right? So what is this in this document? In this document we have some metadata information which is automatically created by the LangChain, because we are using this text loader, and after the metadata we have this page content. Okay, so the main thing, page content. So how to access it? We will access it using we have to use the first index, 0th index, and dot page content, like this, and we can see the preview of the page content. Okay, so now we have in the graph, now we have the page content in the text format. Okay, so we have done that. Now what we have to do, we have to divide it into chunks. So how to divide it into chunks? So we divide it into chunks using, we have this text splitter, recursive character text splitter from LangChain. So we will import it from LangChain, and now we have to use it. So how to use it? This is a code of it. What is the code? Like we have to initialize it. We have to give the chunking size and chunk overlap. What is this chunk size and chunk overlap? For that, I help you with this visualization. Like you can see that this is some text which we have, and we have used, for example, we use this character splitter of LangChain, and we define chunk size. What we have defined chunk size here? We have defined chunk size 200. So I am defining chunk size here 200. Okay, and what is the chunk overlap? Chunk overlap is 20. So what we have done here, the LangChain character text splitter, what it has done, the complete text is divided into chunks of size 200. Like you can see the blue color is going to a 200 character chunk, and then there is some overlap also, like this 20 chunk overlap is we can see by the overlapping of the colors. Like the blue color chunk and the yellow color chunk is overlapped. So this is called overlapping. So why we do the overlapping? We do the overlapping so that we can retain some context and retain some linking between the chunks. So there is no hard and fast rule of the chunk size and the chunk overlap. You just have to experiment on the on yourself, like on your use case, and see what is working fine. So for this case, I am just keeping the chunk size to 200 and chunk overlap to 20. So this is how we have initialized this recursive character tag splitter with this chunk size to 200 and chunk overlap 20, and now we will use it. So how we will use it? We will just pass this pass our documents into the tag splitter. Okay, so we are just using this method of tag splitter. Okay, I am using your method split document, which will take this document and give me the chunks of it. Okay, so here I have the chunk, and I will just preview it. Chunks. Okay, I think I made some mistake here. Yeah, so you can see the whole file. Firstly, we have converted into the chunks, and then we can see the chunk is here. Like we can see there are multiple documents now of the lag chain here, and we can see there are multiple metadata and page content divided into chunks, and they are overlapped also according to the configuration we have given above. So we firstly need to install the vector store, which is Fias we are using here. So I am just installing it here, and now we just need to import it. So here is the two things what I am doing. I am using a OpenAI embedding model, and then I am using this vector store of Fias. Now I will initialize the OpenAI embeddings. I will now create a vector store. So for creating a vector store, what we do, we are creating it using Fias, and we are creating this vector store from documents, and we are giving this Fias this text chunks which we have created above. Like here we have created these text chunks and the embedding model. So in the backend, this will create a vector store with the help of this embedding model using this text chunks. So we will have that in a while. It will take some time, and in the 4 seconds it will create a vector store here. We can see it in the memory also. Like here we can see this vector store is present in this memory location. So now we have what we have done. We have configured this vector store. We have created these chunks. This vector store has this chunk and these embedding models. Okay, and in this vector store our extracted data, our data is stored in the form of embeddings also. Now what we have to do, we need to do data retrieval. Okay, so what is data retrieval? Data retrieval is a simple phenomena which happens when basically, for example, let's take example that this is a user. This is a user working in a company, and it asks, the company has a RAG application running, and the RAG application stores the policy related to the employment. Okay, employment details. So this user asks, okay, what are my working hours? Okay, what are my working hours? LLM does not have this context. Okay, what is his working hours in this training data? But in the in the vector store, this data was available. The company has put in it. Company has embedded the data in it. So what will happen? This question will convert into embedding. And a similarity search will performed with this question in the vector store, and the similarity search will perform in the vector store using this query questions embedding, and the data which is present nearest to this question embedding will be retrieved from the vector store. And how many data will be retrieved? It will depends on the k value. Like for example, this k equals to if k will be equal to 5, then the top 5 data points which are closely placed, which are nearest to this embeddings made by this question will be returned in this top k value. Okay, and the top k results. So we will get like, okay, this top 5 results are matching in this vector store in the data which were stored in it. So this top k results plus this user question will be go into the LLM, and we will get the desired output. Like, okay, your working hours are 9 hours from 9 to something like 6. Okay, so this is how this data retrieval works. So now let's see how this works in a code. So let's go to the Jupyter notebook and let's code it. So for data retrieval, I have made this code. So we are just performing a very simple query that, okay, what is this key characteristic of agentic AI? So this is the query. Like here is the query. Let me write it for you. Here is the query. Yeah, here is the query. So now what will happen? We are just running this similarity search here. Okay, now vector store, run a similarity search with this query and give me the four topmost matched result with this query, and I will just displaying the topmost result. Okay, so here we have got the topmost result, like first is agentic AI systems are distinct from traditional AI due to this characteristic, and we are getting this preview. Okay, these are not full documents, we are getting the preview. So this is how this data retrieval works in the RAG application. So now we have what we have done, we have run the similarity search using this query and we get the top k result, and here are the top k result, like for the 3 4 why 4, because we have k4. So we have this 4 results here, like here we have this 4 result. Okay, as you can see, yeah. So here we have this 4 result, and here there was query. So now what will happen, we will do data generation. So what we have done data ingestion. Then then when the user asks a query, firstly what will happen, data retrieval will happen based on the question the user has asked, and at last data generation will happen. In data generation what will happen, the user question and the top k results will get combined and will send to the LLM, so that LLM can answer. So the same we will do in the next few minutes. So let's code the data generation. So for that we need to prepare the prompt here. So I am using chat prompt template from LangChain, and in this you can see this template. This is a simple chat prompt template which accepts two inputs, which is questions and context. So we will give it later, so you can read it, like we have just written that, okay, take the context also, take the question also, based on the both, give me the answer. So let me run it, and you can see the chat prompt run. Now I have to prepare it, like we have initialized this chat prompt template, and from this template variable I am initializing it, okay, using this method. So in this prompt I have this template in the form of chat prompt template. Okay, as you can see, if I run it, yeah, here you can see that we have this chat prompt template in which there is two input variables, which are questions and context, and then there is this complete you can see you are an helpful assistant, like that. Okay, so this is how we have created a template. Now we have to create another thing, which is a string output parser here. So what is a string output parser? Think of it like it will get an input in for example a dictionary format or in some other format, and it will convert it into a string and it will present it into in the output of it. So it will just convert the input data, which can be in a various format, and it will just convert it into a string and give it to us as an output. So this is the string output parser which we get from LangChain. And then what we have to do, we have to load our LLM. So for our use case I will use Foro Mini. So for that I have to import this chat OpenAI. Okay, chat OpenAI also, because I'm using it here. So this, you can see the GPT-4o Mini is ready for us using this chat OpenAI, which is the class which has given us by the LLM. So we have the LLM ready, we have the prompt ready. Now we have to just connect our questions, like we have to just pass the question, the context to the LLM, and we will get the output. So how to do it? We have to create a chain here. So here is a chain which you have to create. In this you can see there is one new thing, which is runnable pass-through. In a minute I will explain you what it is. So here is the code. So I am getting some error, like retriever is a problem here. So why is the problem the retriever is here? So I am getting this error because I have not defined this retriever here. So what is a retriever? Retriever is simply, you can see I have written this here, like you can see that what I am doing here, I am saying that, okay, vector store act as a retriever. So why I am creating it? Because when I convert when I add a wrapper of retriever into the over the vector store using the LangChain, the LangChain will able to call this vector store as a function in the code flow. So you can think like that. So we have converted this vector store as a retriever, and we will use it as a retriever in our LangChain, so that we can use it as a function call, so that we can index or we can perform some manipulation with the vector store as a function in the LangChain. So for that we have done that. So we will run it. So we will get this retriever, and now we will run this chain. Let's understand how this chain is working. This chain, firstly the input of this chain will go into the retriever also, and the runnable pass-through also. Runnable pass-through is nothing but it's saying the chain that, okay, the input you got keep it as it is and place it here. Like for example, I give the input in the chain like y, so the exact y will be placed in the form of runnable pass-through. So this is the meaning of runnable pass-through, and the y will also go into the retriever, and this retrieval will run with the input of y, and it will provide some output which will be present here. For example, the retriever gives us x, then here x will be written, here y will be written, and this whole object will go as an input into the prompt. Okay, and it should be gone as input, because prompt accepts two variable, context and question, which we have seen above. Like we can see that here it requires a variable context and question, so we are doing the same. This whole object will go into the prompt, and the prompt will return us a full prompt with the input variable of context and question, and the whole prompt with the context and the question will go into the LLM, and at the end the LLM output will be converted into string using the string output parser, which we have taken from the LangChain, and at the end we will get the result in the string. Okay, so for that we have created this LangChain, and now we have to just run this chain. So how to run this chain? We use a invoke function here, dot invoke, and here we can pass anything, like any query which is related to this. Like I can say that tell me about agentic AI, and if I run it, it will basically call the LLM, and then here we can see the output of agentic AI represent a new paradigm in artificial intelligence, like that you can see. So you can see this is based on the text we have, like robotics. We can see if it is present in the, yeah, robotics is present, so it is giving us the output based on the context we have given using the RAG application. So this is how to code a simple RAG application, but we have coded the RAG application in a Jupyter notebook. But further in the session, we will see how to code this RAG application in a fully modular fashion. So I hope you guys understand what is RAG and how it works, and how to code it into a simple manner, like we have seen that how to code it into a Jupyter notebook. And now let's go ahead and go with the next agenda, and let's see what was our next agenda is. So our next agenda is basically setting up logger and exception modules. So what is logger and exception? Logger is basically in any coding application, when we run it, we produce some log so that we can easily see that what is actually happening. If we don't have any logs, we will never know that what is actually happening in our application, and we will never able to identify what where is the problem is happening, or how our application is behaving. So logging is very important. So for that we are creating this logger, and exception is like that whenever we use a try catch block, we raise an exception, right? For example, if some code doesn't works the way we want, then we throw an error. So this error is also a part of exception. So for that we are creating this exception, right? So here we will implement this logger and exception. So let's go into the project directory and implement this logger and exception. So before even implementing this logger code, okay, we need to install our dependencies. Okay, so for that we need to set up our requirements.txt. So I have already prepared the set of requirements we want for our project. So here is the requirements we want. So I have already added it, and now I will uv add our requirement.txt, and uv will just add the packages, and I will just do uv just sync, so that the packages are synced and it's working. Okay, so now we are, and dependencies are also installed, and now we are ready to implement the logger code. So for that, whenever we are creating a modular project, we need to create this for any Python project, any directory to be identified as a module, it need to has a file which is an init file. So it will be created like this, and 2 underscore before init, 2 underscore after init. This is a file name which must be there, so that this logger can be identified as a module, and we can import any of the method present in the logger in the code anywhere else, so that our logger directory will be a module in the project. So we have created this init.py. We also need to create this init.py in all the other modules we want. So I will just copy and paste this init.py in every file. Like here I have also done, here I have also done, here I have also done, here I will also do it, and here I will also do it. Here I will also do it. Let this source for now. Okay, so we have implemented this, we have created this init.py. Now let's create a logger, and here is a code of our logger. So let's place it here and let's understand it, what actually is happening. So we have created a custom logger class in which there is this two method. The firstly is initialization method and the second is get logger method. So how it works, it basically, let me hide this and let's understand. So whenever someone initialize this custom logger class, and it can accept a input which is logs, a log directory, for by default it's logs, and then this log directory will be created as a self variable, and this log directory will be created based on the log directory path we have created, and it will create with a timestamp. So this code is related to the name of the log file, and the name of the log file will be created according to the time of the creation of the log file, and then we are just storing this log file path in a self variable. Okay, so whenever someone initialize this, two things will be done, and whenever there is another method we have, which is get logger, this will be mainly used to get the logger of any of the code. Okay, so let's understand it from the top. So firstly we are creating a variable logger name, and then you can see here we are just configuring the logger for console and file, like we are configuring so that the logger will work for the file handling also, for someone if someone runs it using the file or using the console. So for that we have done here, and here we are just configuring the logging module, like this logging module, and here we are configuring the struct log module. So we are making sure that we are ready for both, like we are ready for console also, file also, and we are giving this log a structure of JSON object, which we are doing it using the struct log dependency. Okay, so this is the code of our struct log of our logger, custom logger. So I hope you understand that, and now let's save it, and now let's move on to the exception module. Okay, so here is the exception module, and in the exception module we need to create a file which will be named by custom exception.py. So let me create a file here, custom exception.py. So custom exception.py. So here is the file, and now let's understand the code in it. So for that I will need these three things: the sys, the traceback, and this typing, and this option and cast. So here is the code for our custom exception. So it uses a traceback. What is a traceback? Traceback we use whenever we need to trace back the origin of the file, like origin of the file or other information. Like you have seen the errors, like okay, the error is coming from this file and at this line. So this is possible using this traceback. So we are using it here. Okay, and what this file do from the overall perspective is that it will just normalize the error message, like the error message we are getting, it will normalize it using the variables we have using the code we have written here, and then it will just try to capture the traceback. Okay, it will try to capture the traceback using this traceback module we have imported, and then it will store that inside the exception. Okay, it will store it inside the exception, and then it will produce a clean string of the logs and the detailed feed traceback when needed. Like okay, so what this file is doing, it will firstly normalizes the error message, and then it will try to capture the traceback if it is possible, and then it will just store the exception, and it will combine this all the three things, and it will give us a nice clean string in the logs. So this is how this custom exception is working, and you can just replicate this custom exception into your projects. You just don't have to understand it that much into a deeper level. Just use it as it is into inside your projects, and configure it using some LLMs like ChatGPT and all, and you are good to go. Okay, so exception is done. So our second agenda is completed, which is setting up logger and exception modules. Now let's move on to setting up the configuration related code into our project. So let's go ahead and go into our project directory, and as you can see there is this config. Okay, so why we are using this config here. So configuration is nothing, it's just the code we use so that we can add our configuration related information, like which LLM model we want to use, what is the output token, which embedding model we want to use. So all this information will be written in this config directory. So how we are going to write it? We are going to write it using a YAML file. Okay, so let's see how we are going to write. So in this config we are going to have this YAML file. So it is not needed here. Okay, and now here we need config.yaml here. This is the file we need to make, and this is the sample config code. This is basically simple YAML file, like we have JSON files. YAML file, the JSON file is curly braces divided, like, and but a YAML file is indentedly separated. But JSON file is curly braces separated using curly braces. A YAML file is separated using indentation. So it is generally used in Python projects. So you can see we have defined an embedding model here, in which it has provided a model name. We have provided a retriever attribute also, LLM attribute also. And this is a structure of configuration made by taking care the further code we are going to do in our project. Okay, so you have to follow the same configuration structure. So this is our configured code. Okay, so now what we have to do, we have set up the config also. We have created this file, but we have not loaded it anywhere. So let's write a code to load this config.yaml file into our project. So for that we will create this file into this utils directory. In this util directory I will create a new file with the name of config.loader.py. Okay, not here, here I will write config loader.py. Okay, this is the file which I am using. So here is the code of that. So in this we are using this path variable and this import YAML. This will use to import the YAML files into a Python project, and we are creating this two functions here. First is project root, this is internal function by this, and this load config. So load configuration, it will take a variable configuration path, and it will return a dictionary with the configuration YAML file details. So it will just take a config path if it variable if it's present in our env. If it is not, it will just try to find the config path using this project root. Like project root will be the root of the project directory which we are on, and in this it will search for this multi-doc chat, and that it will search in the config, and it will find it here. So this line will help us to make it find. Okay, so this is how it's doing. So it will get this configuration path, and if it get this configuration path, I will get the path of it using this path library, and then I will just open the path and load it using this safe load function which is provided by this YAML dependency. Okay, so I will have, and I will return that in the dictionary format. So this file config loader will do what it will do. It will just take the YAML file, and it will convert it into a dictionary using this YAML dependency by this safe load method. Okay, so this is how we have done this config loader. So what we have done, we have written this config.yaml file. We can also write some more configuration. You can also write some more configuration details according to a use case, and then we are just loading it using this config.loader, and it will return us this whole configuration into a dictionary format. Okay, so we can use it in the project anywhere. So we have also made our configuration ready. The next step is to create Pydantic models. So now let's understand how to integrate Pydantic models, and before that we need to understand what is Pydantic models and why we use that. So in any application we want a particular structure of outputs, or we want to keep in check that okay, if you are passing something in this function or in this class or this object, the passing value should be in this format. So now let's create another utility function which we want, which will be model loader, and this will not a Pydantic model, it will be a LLM model. So we will create a file to import LLM models inside our project. So let's code it. So firstly I need to create a file in it which will be model loader.py, and in this I will write this code, like I have write this code, and in which you can see I have imported this AI embeddings from Google and Gemini model, and this chat grok, and the global logger is log, which we have created a custom logger, and the custom exception is document portal exception, and we have imported this also like load env load config, as you can see. So what we have here, we have this two classes. The first is API key manager. So in this you can see we need this two API keys, and it has a init function. We have created a variable which is API keys self variable, and then we are checking that if we have in our env, if we have some environment variable like API keys, so in the raw, so the API key will be installed in the raw. So I have removed the code which that was not important. So here we have what you can see here. We have this using this required key variable. We are just iterating on that, and we are seeing that if in our API keys or self, we are just getting the API keys from the env variable, and we are loading it. Okay, so this the simple thing which we are doing here. So we are just loading this required API key from the environment.env file, and then in this get we are doing the same. And the model loader is the main class here. What model loader is doing in the init function, what we have, if we have the if we don't have the production boolean turned on, it will just manually load the envs present in the .env file, and it will just use this API key manager, and in the return what we get here, we get the API key manager, and using this load config we are also loading the configuration things and the API key manager, and we are using this load embeddings here. Okay, we are on the model loader, right? So in the model loader, what we have done, we have stored this initialization of API key manager class in this self variable with the name of API key manager, and then we are also loading the config.yaml file using this load config function inside this self.config. Okay, config variable of self. And now in this model loader init, this is done. Now what is this load embedding is doing? Load embedding, as the name suggests, it is just loading this embedding model present inside this configuration config.yaml file. So how it is doing it? It is just using in this try block, it is what is doing, it is using self.config, and in config what we have, in config we have the information of the config.yaml. In that it is using that, okay, give me the embedding model, which embedding model it is using, and in that it give me the model name, like that it is doing. So for example, if you will open the config.yaml, you will see that it will give me the embedding model and give me the model name, so it will return this there. Okay, so it will return this there in the model name. So we are just logging the information that model name this is open, and using the model name we are using Google Generative AI and giving the AI embedding and loading the embedding using the model name we got. Okay, and using the API key manager initialization we got in the variable of self, we are getting the Google API key, and we are providing it to the generative Google Generative AI embedding class, so that it can generate a embedding model for us. So this function is also done. Now let's understand this load LLM. So load LLM, as name suggests, it is loading the LLM according to the LLM which is given inside this config.yaml. So firstly, it is what it is doing, it is just fetching this LLM block using this config LLM. So in config it is fetching the LLM block, like this is fetching this block, this complete block will be present inside this LLM block. Now what we are doing, we are getting this provider key. If this provider key is mentioned in this in the LLM in the .env, so we have to mention a LLM provided in the .env, and we have to give a value like Google or Grok. So if no value is present, Google will be given as it is. So provider key will get that, and if provider key is not present in LLM block, we are raising the error, and we are just getting the LLM configuration. How we are getting the LLM configuration? For example, we have provided the key Google, then the LLM block will get the Google block. Like here, LLM block will get the Google block, and all this information will be present inside this LLM configuration, and it will just fetching the separate details like provider and model name, temperature, and all using this config.yaml. So this is how we are doing that. So at last we are just we have written this main function file if you want to load that. Okay, so model loader is done also, and now finally we can move on to understand this data ingestion and document chat. Okay, So firstly we are going to understand this data ingestion code, and for data ingestion code let's go ahead and define this model loader. Firstly handle all the errors we are getting. So now understand the code of data ingestion, which is coded in a modular format. Okay, so we have created a class which is chat ingester, and then we are just initializing it. It will take 4 variables. Firstly understand that this code will look very difficult at first, but when we use it using the flow, and firstly you will revise it using by going through it 2-3 times, it will be very easy for you. So firstly understand with me like what is written, why it is written, and then go through it once again and twice again, write the flow into your notebook and trace it back again and again, and you will get to know how it is working, and you will find it easy then. Okay, so let's understand this class chat ingester and why it is written here. Let's understand the init function. Let me minimize the functions. Okay, so in this chat ingester we have this 4 functions. The first is initialization function. It will run when we initialize this object for chat ingester. So in the object what we have to do, we have to provide this 4 variable: temp base, fires base, use session directory or session id. So temp base, what is temp base? It is the temporary data directory from which the chat ingester will fetch the data to ingest into the vector store. And for phase bias, fires base, what is this directory? This directory will contain the vector store. And use session directory like session based directory. So it is saying like use session based directory for fires and temporary data. And session id, we can give a additional session id, manual session id to it also, but it is optional as you can see. So now let's understand what is doing. In the try block we can see that we are loading the model using this model loader class, which we have implemented a minutes ago. And then here we are using this session directory, use session, we are storing that there. And then we are saying that cell.session id equals to session id, and if it is not present, it is saying that okay, generate session id, but this is not defined. So where it will be defined? It will be defined in the utils. So we will create another function, another functionality. For that we have to write another file, which is file file.py. So in this file we will have this so for now we are going to remove it, and if we need if further we will create it, okay, in the further sessions. So for now I'm just removing it, and it will just store the session id which we got in the initialization. And then what we are doing, we are just making the directories which are given to us during the initialization of the object, like temp base and bias, fires base, and storing that in the self. And then we are just using this resolve directory function, which is an internal function. So what it is doing basically, it is doing like it is just creating a directory if it is not present, and it is using a fallback also, like here. So this is just a utility function which you can see. So let's go back, and this is done, and our chat ingester is initialized. Okay, so our chat ingester is initialized, and in the initialization what we have done, we have just basically we have loaded the model using we have loaded the model loader in the self, and we have set up the directory in the project. Okay, so that the chat ingester can work on it. So this is how it's done. And now let's understand the another function which we have given here. So what result directory is doing, result directory is just taking a path, just taking a base here like path, and if the use session is used, what it will do, it will take the base, and it will add the session id on it, and it will create the file under that. So it is just adding the session id inside the base directory which we have created, so that we can have session based directories. Okay, so this is the result directory function is doing. The another is split function. What split function is doing, split function is basically used to create chunks from the text we have. Like you can see that it is importing this recursive text splitter from the LangChain, and it is splitting the document which we have got from the split method. Okay, and it is just logging that, and it is returning the chunks. And so split is also done. And what is this build retriever is doing? What build retriever is just, so here we can see that we are getting this save uploaded file is not defined, and load document is not defined. So we have to define that first. So let's create this utility functions also. This is also a utility function which will present inside this file IO, and let me create it. So in this file IO I will create that upload files, and I think we have to import that also, like here. So I have created this new file, which is file io.py inside this utils, and inside this, as you can see, we have created this save uploaded files function. This save uploaded file, what it is doing, it is basically checking that if is this support is this extra checking that is the uploaded file from the user, is it coming inside this supported extension or not. And if it is not coming inside the supported extension, it will throw us an exception. And if it is coming, then what will it will do, it will just create a copy of the uploaded files inside a session based directory, which we will see in a while when we run the project. And the file name will be written in a UUID manner, like you can see, like the f name is UUID manner. So we get a very clean looking file, like we are creating a session inside the session we will have UUID named file, okay, of the uploaded files by the user. So here this utility function is done, and now let's go back to this, and now it is showing that okay, we have also a missing function which is load documents. So now let's add that again also. So for that I will need to create another file inside this util, which will be document ops.py. okay, inside this document ops.py I will need to write this. So as you can see, we are using this PyPDF loader, doc2x loader, and text loader. Text loader we have seen in the beginning of the session. It is just getting the text file, and it is giving us the LangChain documents of the text in the form of page content along with the metadata. So similarly, PyPDF loader will do what PyPDF loader will do. PyPDF loader will extract the page content from the PDF, and it will give us the LangChain document with the metadata and the page content of the particular PDF. And same goes for docx. Okay, so we have used that here. And in the load documents, as you can see, it is getting the paths in the iteratable manner, like multiple paths, list of path we are getting, and it will give us a list of documents. So it will get the path, like the path of the PDFs, the path of the docx, or the mixture of both, and it will check if in the path, if the suffix of the path is PDF, then it will use the PyPDF loader. So and initialize it into a loader variable, and it will just load that inside this doc. It will just load, so we get the LangChain document, and it will just extend the docx. Like here we can see this is an empty array, so it will just add the extracted extracted LangChain document inside this docx empty array. So at the end, what we will get, the whole paths with the docx or the PDFs. We at the end we will get a list of LangChain documents with the page content and metadata of the provided PDFs and docx. So this document load documents will do this. So let's go back inside this, and we have to import it also. So from utils document ops and load documents, right? So we have loaded the documents, and like save uploaded file, what it was doing, it was taking the uploaded files and the directory, and it is creating the UUID based name copy of the file uploaded by the user. So we will get a session based data also of the user. Okay, so and the copy it makes, it will return us the paths which will stored in this list, and the list of paths we are providing to the load documents method. In the load document method, we seen that what it is doing, it is providing us the LangChain documents. Okay, it is providing us the list of the LangChain documents which has the page content and metadata. Okay, so in this docx we have the list of the LangChain documents. So what it will do next, it will just split what split was doing. Split was creating split was creating chunks. Okay, so we are providing the list of the LangChain documents and the chunk size and chunk overlap, and it will just give us the chunk using the recursive character text splitter. And at the end we are calling this FiAS manager class. Okay, so what FIS manager class is doing. At the top, FIS manager will create us a initialize as a vector store, a empty vector store with the and also initialize the particular embedding model. So it will create a vector store which is empty with a embedding model. So and it will give us okay. So we will look into the FIS manager. I am just providing you the overview of it. So now if we are creating these two variable text and metas. What is text and metas? From the chunks we are extracting the page content and storing it into a array. So all the page contents of the chunks will be stored in the array in a ordered manner. So similarly the metadata will be happen like for chunks, all the chunks we are getting the metadata and we are storing it into the list. So this two sorted list will contain the metadata and text. So now what we are doing, we are using the same FIS manager initialization and we are using this load or create. Okay, so for understanding of this, let's see what this FIS manager class is doing. So in the initialization, in the initialization of the FIS manager, we can see we are initializing this index directory. What is this index directory? This index directory is a directory where we want to initialize the vector store, and we are just creating the directory which was given into initialization, and we are creating this metadata objects also so that we can store the metadata of the ingestion of the data. And we have created a self variable of meta path, and we have created this internal variable meta, which is a type of dictionary, and it accept key as a string and a value of any. Okay, so it will be like this. So we have initialized this meta self variable, and it will be this dictionary with a key row and an empty object. Now if this meta path already exists, for the particular path manager, we are loading it using this JSON, and we are reading it using this UTF-8. Okay, so in this meta variable we will get the existing meta data if it is available, and if it is not available we are just keeping the same, like the metadata variable as the same, the empty one. Okay, and here we are also configuring the model loader also, and we are loading the embeddings. As I have said that using the model loader we are loading the embeddings. Okay, and we are initializing a empty variable which is of type FIS here, and this is optional. Okay, so in the initialization of the FIS manager we done that. And what other method we have this exist. What exist will do, exist will just check if the FIS index or the vector store of FIS is already exist or not. If it is, then it will return true. If it is not, it will return false. Okay, and this is a static method. For now we can just ignore it, we don't need it, we will understand it later. And this is a save metadata, like it is, this method will use to save the metadata of the written text inside the vector store. Okay, and this is a add document. This is a very important method. What it is doing, it is checking that if self is none, so it is expecting a vector store inside the cell, inside the VS. So if it is none, it will just raise a runtime error, and if it is not, it will go ahead, and we are just initializing a new doc variable which is a type of list of LangChain document, and it is empty array. And in this docx which we are getting from the function itself, which will be passed in the function, and in the docx, for every docx we are creating this fingerprint along with the metadata, and we are appending it into a new docs. Okay, and we are appending the new docs inside the metadata. As you can see, this is an overall view of the code, so you just don't have to go into the deep that much. Or this is the last thing, which is load or create. What load or create is doing, load or create is firstly checking if the vector store already exists. If it is already exists, it is just using the existing vector store and loading it and returning it inside the self keyword vs. Okay, and if it is not present, then it is creating the vector store from the scratch using the text we have provided inside the function of load or create. So I hope you got the understanding of what FIS manager is doing. Now let's go back to the chat ingester and see how it's working. So we have initialized the FIS manager, and we are using this load or create function which we have seen, which will create a FIS index from the scratch using the text and the metadata. So it will create a FIS index using the text and the metadata, and it will return the vector store inside it. So inside it we have the vector store. Okay, also we have the add document. So add document, what it will do, it will add the documents along with the metadata using the FIS. So the documents are also added, and here I have remove the MMR code for now. We will understand it later. Here we are just using the simple simple search, similarity search, and we are just passing the k as it is, which was given inside this build retrieval. Okay, so what we have done, we were understanding this chat ingester, and we were on the add documents. We have seen what add documents will do. Add documents will give us the document with the metadata, and finally what we are doing, metadata, and along with the metadata it is storing the documents inside the vector store using the embeddings, okay, which we are created using this FIS manager. Okay, FIS manager class. So at last what we are doing, we are configuring the search keywords, key arguments. So we are passing it is k as we have got as an input in the function. And at last, what we are returning, we are returning the vector store, the VS we got from the files manager as a retrieval, and we are telling that okay, use search type as similarity search and search keyword as k equals to k, like that. So at last, from this built retriever, we get a vector store as a retriever, and we can use it later as a function in LangChain. So I hope you got the understanding of how data ingestion is working and why these two classes I have written here. Okay, so let's go ahead and code the document chat. Okay, so in document chat, we need to create a file which is retrieval.py. Let me check the spelling, retrieval, retrieval.py. So in this, we have this code, and let's understand what it is doing. So it is giving me an error, let multi-dollar prompt library. It is not. So let's comment it for now, and we will resolve it later. Okay, so let's understand it for now. So in this retrieval, we have this class conversational RAG, this single class we have. Okay, and in this, what functions we have? We have so many functions like here. Okay, so now let's understand it one by one. Here we can see in this initialization, we are getting this session ID. Okay, we are loading this LLM. So how we are loading? We are loading using this internal function which is load LLM. So let's see how it is doing. So what is load LLM doing? Okay, it is using the model loader class, model loader module which we have created, and in the model loader it is using the load LLM. What was load LLM doing? Load LLM was using this load LLM block from the config.yaml, and it is getting the provider key from the .env, like LLM provider equals to grok. So it will get a provider key, and according to that, according to the key, it will fetch the provider name, model name, temperature, max output token. So this is done, right? We are loading the LLM, and we are just returning the LLM as it is, which we get from the load LLM configuration. So we have this LLM information here. So now here is two things, like contextualized prompt and QA prompt. Okay, so for now, okay, let's do one thing. Let's see what it is. So firstly, it's saying that prompt registry is not defined. So let me resolve it. So to resolve it, basically we are missing this prompt library inside this prompts. So we need to create a prompt library inside this prompt directory we have. So how to do it? We need to create a file which is prompt library.py. Okay, and in this prompt library.py, we will write this code. Okay, so what it is doing? It is using the chat prompt template and message placeholders from the LangChain core prompt, and we are defining these two prompts here, like a contextualized question prompt and contextualized question answer prompt. So what it is and why it is working, I will tell you when we are running the flow. Okay, then you will get a better answer. For now, if you are coding along with me, just write it down here so that we can run the file, and during the run we will understand it. We will understand it much better. So for now, just write it down. So let's go back to the source data retrieval code, and let's understand it further. So we have defined it, like we are just getting this contextualized prompt inside this self and QA prompt inside this self, and now we are just lazy loading this retriever. Are we getting from where we are getting from this initialization. If we get the retriever initialization, we will store it already, and if we not, we will get it as a none. And we are also creating a chain variable inside this class, and if it is not none, we are directly building this LCEL chain. So we will see what is this. So I hope you got the init function point. Okay, now let's see the other functions also. The other is load retrieval from files. What it is doing? It is just basically getting the load embeddings, like functions from here, getting the embeddings, and using the embedding, it is creating a vector store. Okay, using local load. Okay, how it is using the local load? Because we have provided a path here already, index path. So it is this function will help us to load the retriever from files if it is already present, and using the retriever, using this vector store, we are creating a retriever of LangChain, and we are storing it inside this retriever, and then we are building this chain. So for building this chain, building this LCEL chain, we need a retriever. Okay, so if we do not have a retriever, we will face some error. That's why we are always running this build LCEL chain after creating a retrieval. Okay, so I think this function is also clear. Now let's understand this invoke function. In invoke function, what it is doing, we are getting we are checking that okay, if chain is null, then what we are going to invoke. So we are going to raise an exception. It is getting a chat history array, it is getting a payload. Okay, let's do one thing, let's ignore for it for now, we will understand it later when we are running it. And here is a load LLM, we have already seen this function. And this is static function, static method, which is just formatting our docs. What it is doing, it is just giving us a page content in form of a string from the docs which it was getting inside the attributes. Okay, and the last is build LCEL chain, and this is also important to understand. Let's go ahead and understand it. Firstly, it is checking that okay, if self.retriever is none, raise an exception. If it is present, then write this question writer rewriter question rewriter chain. This chain we will understand when we will run the code. Okay, just keep in mind. So I think this overview of the conversational RAG retriever.py is done. Let us try to run this code and see if there is any bug. We will resolve that, and after that we will understand it once more, so that you will get a clear understanding of how the other functions which I have told you, I will explain later, works. Okay, so let's go ahead and write a code to run it. So to run it, I will create a new file here, which is test.py, and in this test.py I have added this code to running the flow we have created, to run the project we have created. So for that I am importing the chat ingester class we have seen from the data ingestion, document ingestion. I am importing the conversational RAG which we have seen from the retrieval. Okay, and then I am just importing the human message and AI message from the LangChain, and then I am just loading the env variables present inside the .env, and then we are defining this function which is test document ingestion and RAG. Okay, so it is firstly creating a test file which is a list of a path of the file. So this is the files which we need to perform our RAG application on, which we need to perform our queries and which we need to ingest in the vector store and perform some queries and find the results. So for now I have kept a file here which is present inside this data directory, and it is not present actually, so I have to paste it. As you guys can see, I have pasted this file, this exact same file inside this data directory, and I have passed this file path. Okay, so to make it like this, I will just remove this. Okay, now it's saved. Okay, so let me confirm it by creating the copy path and just pasting it here like that. So now we are absolutely fine that okay, test file, we have this file as a source. Okay, now we have created an empty array which is uploaded files, and we are iterating on this test file array, and for every path we are firstly checking if it is exist. If it is exist, then we are adding this test file in the binary format. Okay, in the uploaded file. So for example, if there was 3 paths, so all the 3 files will be opened as a binary and appended inside this uploaded files array. Okay, and for and then we are just initializing the chat ingester which we have already seen. Let me help you to revise that how it was running. It was just basically, firstly it was setting up it was getting the temp base, fires base and use session directory, and using all this information it was setting the model loader and also the setup directories of the fires and the temporary data. So it was doing that, and now let's go back to the test. Yeah, so it has done, it has taken the temp base, fires base and session directory, and it has configured the chat ingester to perform the vector store operations, RAG operations on this directory, and it has also loaded the model for us so that we can extract the embeddings from it. Okay, so here we have this. Now what we are doing, we are running the build retriever function from this chat ingester module, and we are passing these things like we are passing this uploaded files array we have, in which we have the binary format of the files we want. Okay, so we are passing it here. So let's see what this build retriever is doing. We have already seen this, but we are now seeing this with the context of the run. So it is expecting uploaded file, so we are giving this uploaded file in this save uploaded files function. What was the save uploaded file function is doing? The save uploaded file function was uploading a copy of the uploaded file by the user inside a project and storing it into a nice session based manner, and the file name will be UUID based, and it is just returning the path of it. Okay, returning saved, like returning saved. What is saved? Saved is the list of the path of the copy of the uploaded files which the project has created for us. Okay, so we have seen what uploaded file is doing. Now this uploaded files will be gone inside this load documents. What load document was doing? Load document was doing nothing but checking that which extension file it was, if it is pdf, docx, txt, and appropriately loading a LangChain document for us, which will have a page content and metadata. Okay, and inside this docx we have a list of this document LangChain documents with the metadata and page content. Okay, page content will be in the text format. So we have that in the docs, and now what we are doing, we are creating chunks. Of what chunks? We are creating the chunks of the docs. So we are using this split function. Split function we already looked upon. Split function, what will do? It will take this docx, and it will just pass this docs inside the recursive character text splitter, and it will create a chunks with the configuration which was given. So what configuration was given? Chunk size chunk, you can see inside the build retriever, we can see during the calling. Okay, so we can see it also, like by going inside this test, we can see that the chunk size was given 200 and chunk overlay was given 20. So similarly the thing will work here, like the chunk size was 200 and chunk overlay was 20. So the docx will be splitted into the chunks with the size of 200 and the overlapping will be 20 inside this chunk. Okay, and now what we have, now what we are doing, we are initializing a FileS manager with the files directory and model loader. What this FileS manager is doing, FileS manager is firstly initializing it is doing, it is storing this index directory inside their self, and then it is making this directory index directory, and then it is just managing the metadata also of the vector data ingestion, and it is just checking that if the metadata exists. If it is exists already in the inside the index directory, then it will load it, and if it is not, it will just initialize this empty. Okay, and it is also configuring as a model loader so that it can get the embeddings, and it is also creating a vector store type vs variable inside the self. Okay, so this is done. So inside FileS manager we have seen what it is doing. Now what we are doing, we are creating a text variable which is a list. Inside this list we have all the page content of the chunks we have created. Similarly in the metas we have all the metadatas of the chunks we have created. Now what we are doing, we are using this load or create function of the FileS manager. So what this function is doing, this function is basically firstly checking if the vector store already exists inside the path. What path? The index path. Okay, the index path, the index files directory path. If the files directory is not present, if the files directory is present, then just create the files directory using the path and using the embeddings and just return it to me. And if it is not, then create a files directory from the text and the metas using the embedding which I have provided inside this load or create, and give me the vector store. So this load or create, what it is doing, it is loading existing files, or it is creating a new files using this text or metadatas and returning us the vector store inside this vs. So this is what it is doing. And now at the end, what we are doing inside this vector store, we are also adding this document using these chunks. Okay, so we have done that also. And what this add document will do, and the add document will handle the metadata of the embeddings which are present inside this FileS manager, and we have this added variable also. And now we are just defining search keywords also, and we are returning the vector store as a retrieval inside this build retriever. So inside this build retriever we will have a vector store as a retrieval. So the return was not important, so we have created it using a underscore variable. And now we are closing the uploaded files because we don't want to leave it open, we don't want to leave the locations open. And then we are creating the session directory, index directory again, and we are getting it from the files index. And then we are initializing this conversational RAG and passing the session ID in it. So for what conversational RAG is doing, conversational RAG is doing nothing but it is just loading the LLM for us by loading the LLM, we have already seen what it is doing. It is using the model loader, and using the model loader, it is loading the LLM which was given inside the env. Okay, using the config.yaml file, and inside this LLM we have the LLM information. And now let's understand what this contextualized prompt and QA prompt I have written. Okay, so let's see. So here we are saying that okay, contextualized prompt is this prompt registry, prompt type, contextualized prompt. So what is this prompt registry is? Prompt registry is nothing but a dictionary which contains this key value pair. So what is this key? What is this key here? The key here is prompt type contextualized question. Prompt type. So where is prompt type defined? Prompt type is defined here. Inside this are models. We have also already defined it. So prompt type saying that contextualized question is contextualized question. So contextualized question will give us the value of contextualized question. So this value will go inside this prompt registry. So prompt registry will look at the contextualized question, and prompt registry will look at the contextualized question, and it will give us this, which is this variable, which is this. So let's understand this contextualized question prompt. It is a chat prompt template in which we are creating a system message first, which is this is very important to understand. What we are doing, we are saying that okay, here is the conversational history till now. Your job is to rewrite the query as a standalone question. Why we are doing that? Because we don't want to give the previous context again and again, like previous chat history again and again. We are saying that okay, here is a chat history. You are here to rewrite the question as the chat history. So why we are doing it like that? We are doing it like that because, for example, we are running this application, and I asked the first question. What was the first question? The first question is, hello there, I want to study about rack. Okay, and then the chatbot answers me, and my second question is, what is the full form of it? In the second question, as you can see, we have not mentioned rag here, and if we pass this second question as a standalone query inside this inside the vector store or inside the LLM, no one will understand because here there is no keyword. So here this contextual question prompt will help us. So what it will do, it will have a conversational history. So it will have this first question. Okay, so firstly the rag question will be asked, like here in the chat history we will have this question, and it will do what it will do. This prompt will enable the LLM to take this conversation history, take this input, and tell the LLM, okay, rewrite the query as a standalone question. Rewrite the query of the user as a standalone question by considering the previous context. And here we have explicitly mentioned that do not provide an answer, only reformulate the question, and if it is necessary, otherwise return unchanged. So we have done that. So we have run this system message, and then we have passed the chat history using this message placeholder, and the input using this input variable. Why we use this message placeholder? Because whenever we want to pass a list of inputs, list of variables, then we use this message placeholder. So for this we use this contextualized Q&A prompt. And why this context QA prompt is written? This is nothing. This is basically telling the LLM that okay, here is the query, here is the chat history. You just have to provide the answer. So this query, this input will be provided from this, the result of the contextualized question prompt. Okay, so this is the way how it works. So now let's see inside the test.py, and you will understand it more. So inside this you can see here we have here we have that in the conversational rag we were there, and in the conversational rag we were there. We have seen that okay, QA prompt is also initialized, and contextualized prompt is also initialized. We are also storing this retriever in the self, and the chain as null in the self, and if the retriever is not null, we are building this LCEL chain. So but for now the retriever is null because we have not passed it, so the code will stop there. Now what we are doing, now we are using this load retriever from FIAS, and we are passing this FIAS directory, index directory, the k value and the index name from the FIAS, and if it is not present from the .env, if it is not present in the .env, we are using it as index. So let's see what load retriever from FIAS is doing. So it is just getting this embedding, and from embedding it is creating this FIAS directory. Okay, and it is just giving us the retriever by making the vector store which we have initialized above as a retriever. Okay, so in the cell we have a retriever which is built using the data of before, of the data we have. Okay, so this is done. Why we already got this retriever? Because we have already created this retriever in the chat ingester. That's why we already got the retriever here. So in this we have got this retriever, right? We have got this retriever. Now we are running this build LCEL chain. So what is this doing? This LCEL chain is basically checking if the retriever is not there, retriever is not there inside this conversation rack, but it is there. We have initialized it, and then we are using this two chains here. So what this is doing? The first chain is question rewriter. What it is getting? It is just firstly the item getter will get the input and the chat history. Okay, and then a JSON will be prepared. JSON object will be prepared, which will have the key input as the same as the input of the user, and the chat history as the chat history, which will store during the run. And then this whole dictionary will be passed to the contextualized prompt, which we have seen. As you can see, the contextualized prompt was expecting input and chat history. Like here you can see the contextualized prompt was expecting input and chat history. So we are giving the same here. Okay, we are giving the same. So we are giving the contextualized prompt, these two things, and the contextualized prompt with this input and chat history will go inside this LLM, and this LLM will give us the output, and the output will be converted into string. Okay, using the string output parser. So this will be the output of the question rewriter chain. Okay, so here the first chain was done. What the first chain has done? The first chain has get the input from the user, the chat history from the user, and then using the chat history and the input, it has rewritten the question so that the single alone question can be used to query the vector store and answer the input from the user. Okay, so now in the second chain, what we are doing, we are using the output from the question rewriter. We are passing it into the retriever so that we can get the top k results, and we are formatting it using the format doc. What is format doc is doing? Format doc is basically providing us the page content in the string format, okay, of the retrieved top k matches. So this is done. So what it will done? It will do, this chain will do, this will take the output from the question rewriter, the rewritten question according to the user input and the chat history. The rewritten question will go inside the vector store. The similarity search will run, and we get the top k result. The top k results will be go inside this formatted doc document, and this formatted doc will give us the text of the top k result. Top k result in the string format will be stored inside this vector doc variable. Now this vector doc variable, okay, and this vector doc variable is using in this third chain. The third chain is pretty simple. Firstly, this JSON object will be prepared. It will get the input from the user input. It will get the chat history. Now using this context input and chat history, all these things will be go inside this QA prompt. The QA prompt is expecting these three inputs, like you can see here. It is expecting this three input: chat history, the context, and the input. So we get this three things, and inside this QA prompt. So this QA prompt will be filled with these three variables, and the whole thing with the chat history, context, and input will go inside the our LLM, and the LLM will give us the result, and the result will be converted into string, and the string will be stored inside this string will be returned by this chain. Okay, so this is how the build LCEL chain works. So now let's go to the test.py here and see what was doing. So we have built this LCEL chain, and it was returned as the thing. Okay, it has set up the chain for us, but now we have not invoked it. So we will invoke it. So where we will invoke it? We will invoke it in a chatting manner. So how we'll do it? We have firstly created an empty array of chat history, and then we have written a loop so that we can prompt the flow again and again until we want to stop. So in this we have firstly taken a user input, and then if the user input is not present, we will continue, and if the user input is some exit quit, we will say goodbye and we will break the loop, and then we are going to use the rag. Like, what is rag here? Rag is the conversational rag, which will have the methods, and it will use this invoke method. Invoke method is getting user input and chat history. Note it down. Okay, so in this invoke, what we are getting, we are using the cell.chain, which we have built from the build LCEL chain. Inside that we have all the three chains set up, and inside that we are using the chain to invoke it, and we are passing in the payload like the input and chat history, and the whole chain will run. The whole chain, like we have seen here, where we have seen the build LCEL chain. Yeah, this whole chain will run again with the input of the payload here. From the here, whole chain will run, and at the last we will see that the chain will invoke successfully, and we will get the return as an answer of the string. Okay, answer of the query we got in the form of string. So in this we got the string, and now at last what we are doing, we are appending the current responses from the human messages and AI messages like from the user input and answer, and we are storing it a chat history. Okay, and lastly we are done here. So now here's the final moment. Let's try to run this code by ourselves, and let's see if there is any issue in the code, and let's try to fix it. Okay, and if there is any issue, so quick fix everyone. What I have done, I have basically getting some error, so I have added a few lines like this. I have in the data ingestion, I have updated some lines, like I have added this extra function like generate session ID, which was missing, and because we are using it here. Okay, you can see we are using it here. Generate session ID, we are using it here. Yeah, here. So we can see, so that's why we are getting the error. So you just have to paste this function generate session ID. It will just create a session ID based on the date and time and unique ID, and it will just combine that to create a session ID. Okay, so this will do it, and the code simply bit was missing, so I have added that, and now everything was working fine, I think. So let's try to run it. So as you can see, our logger was working, and our logger was perfectly working. As you can see, the models were also already loaded. We can see the API key is also, the loading of the module is also done, and we can see the index name is also index, and LCEL graph built successfully. We are getting all the logs. Okay, so now it is saying to chat. Okay, so let me see the paper we have ingested. It was about this attention is all you need. It is a very popular paper in this data science field. So it is a very popular paper. So it is about attention, I think. Na? So let's ask it about what is attention. What is attention? So as you can see, it is giving me attention is a mechanism related to different position. It's compute on a set of queries simultaneously. So it is giving me an answer based on this file only. Okay, so let me ask something more, like what is the encoder. Like you can see, it has given me answer that encoder maps an input sequence of a symbol representing to a sequence. Like here somewhere we can find this answer. So our code is running, and as you guys can see, inside this data we can get a session based copy of the file the user is running, like that we are getting that. So we have implemented a pretty nice project where we can see that okay, the copy of the data is also storing session wise, and also you can see that a FIES index is also created. Inside that we can see the session based FIES index is created with the metadata, like we can see the row we have, and then we have this logs also, like this is also some UUID based, and you can see all the logs which are already stored in this. So this is already a production grade, and this is already a very modular and scalable application.